Okay, so this problem deals with several concepts from physics, and the first one is going to be how gravity affects an object. So we have block A of mass 4 kilograms is on a horizontal frictionless tabletop and is placed against a spring of negligible mass and a spring constant of 650 newtons per meter. On the other end of the spring is attached to a wall. The block is pushed toward the wall until the spring has been compressed to distance x as shown above. The block is released and follows the trajectory shown, falling 0.8 meters vertically and striking the floor a horizontal distance of 1.2 meters from the edge of the table. Air resistance is negligible. So the first part is calculate the time elapsed from the instant the block leaves the table to the instant it strikes the floor. So in the vertical direction, there's actually no initial velocity, and gravity is affecting the block. So I use G as negative 10 meters per second squared. You can use negative 9.8, but for the sake of the AP test, which is what this problem comes from, you can use negative 10, and that's acceptable. We also know that its displacement in the y direction is negative 0.8 meters, and we know its initial velocity in the y direction is 0 meters per second. And we don't know its final velocity in the y direction, so we're not going to use that piece of information, and we are actually looking for the time that it takes to do this. So for the physics question, you really need to think about what formula you can use that has the three things you know and the one thing you're looking for, and in this case you're going to be using delta x, or I call it delta y because we're in the y direction, is v initial in the y direction times time plus 1/2 a t squared. We have our initial, or delta y is negative 0.8 equals, we don't need this because it's 0, and we have 1/2 times negative 10 t squared. So we have negative 0.8 equals negative 5 t squared. So we divide both sides by negative 5, so we have t squared equals 0.16, and so t is the square root of that, and you get 0.4 seconds. Okay, so we're going to be using that information in the second part. In this part, you want to know the speed of the block as it leaves the table. So in the horizontal direction, gravity doesn't affect it, and your acceleration in the x direction is 0 meters per second squared. So we know that the velocity, which is displacement over time, isn't going to change for that whole section. We actually know the displacement, and we know the time. The displacement, the object goes 1.2 meters, and the time it takes to do that is 0.4 meters, 0.4 seconds. And so we get that it is traveling 3 meters per second. Calculate the distance the spring was compressed. So for this problem, they're actually kind of asking you to know the conservation of energy. The conservation of energy says that the energy you have going into the problem is going to be whatever energy you have at the end of the problem. So I'm going to make the beginning of the problem right when you compress the spring. So we have potential energy for the spring. There's no other types of energy in this case because we don't have gravitational, since I'm going to define the end of the problem right when it reaches the end of the table. You won't be using kinetic energy because the spring isn't, the object isn't moving yet. So all of that energy gets converted to kinetic energy of the block. And again, there's no gravitational energy, there's no spring energy at the end. So what we have is that 1/2 kx squared will equal 1/2 mv squared. We know a lot of this information, so the 1/2s will actually cancel. We can divide by k, so we have x squared equals mv squared over k. X is the square root of mv squared over k. So we have the square root of, our block is 4 kilograms. Our velocity is 3 meters per second. squared divided by our spring constant, which was 650 newtons per meter. And so we get the answer of 0.24 meters. So the spring is compressed 0.24 meters to make it have enough energy to do that.